is our antiderivative? We evaluate it at 2. Minus it evaluated at -1. So 8 plus 8 minus
Oh yeah. I was like, I got
1/2
That's the same.
plus 2. So minus 5/2. 16 minus 5/2, 32.
Plus 8. 16 inches the same as
12.
32.
32 halves minus 5/2 is 27 halves. What do you got? 27 halves.
I got the
13 halves. We'll call that y equals x squared minus 2. If I integrated x squared minus 2 from 0 to 3, we would be finding this area, and then where does it cross? X squared equals 2, x equals plus or minus the square root of 2. Square root of 2 is somewhere between 1 and 2. And it goes out to, we'll say 3 right here. So do you think you're getting a positive or a negative answer here?
Positive.
Because there's more
area positive.
positive area, right? So if this were a velocity equation, and we want to find the integral from 0 to 3, we found the distance or the displacement between 0 and 3. Do you think we'll be from where you started to the right or to the left?
Positive.
To the right.
This would represent positive. This would be negative. So if I started here, I would end up somewhere to the right. Somewhere over here, right? Because there's more positive area. Positive area would represent a positive displacement and a negative displacement. Okay, so if I wanted to find the average area of the red right here, the average, you'll be asked this will be on the AP exam. What is the average of this function from 0 to 3? You integrate it, and you divide by b minus a. It's like, if you want to find the average age here, we add up everybody's ages, and you divide by how many students we have. Here, we add all the area and divide by how far we've gone. So the formula would be 1 over b minus a, integral from a to b, f of x dx. That's the average. But this is basically just dividing by b minus a, 1 over b minus a. So let's figure out, let's see, 1/3 x cubed minus 2x from 0 to 3, 27 over 3, 9 minus 6. So actually the area is 3, right?
Mm-hmm.
Oh yeah.
So what would the average area be?
1.
It'd be over 3 minus 0, so it'd be 3 over 3, which is 1. Okay, so that's the average. So if this was, like in Superior, if we figured out the average temperature throughout the 12-month cycle,
That's
Does
not
not look accurate at all.
way too high.
Not enough negative at all.
Yeah.
So if this is 0 degrees, average temperature,
We're gonna die.
like in mid-August, we finally get above 0.
Yeah.
There you go.
Just for my birthday.
So if you wanted to find the average temperature of Superior, and you had a graph to represent the temperature, you could just find the area under the curve and divide by, it'd be 12, I guess, because there's 12 months.
Why is January so hot?
We'll call this January.
Alright.
Okay, so average temperature, or average of anything, you just integrate it and divide by b minus a. So do you think there was a point in this interval from 0 to 3 where the actual graph was equal to 1?
Yes.
Yes. Mean value.
Like, maybe like right here, right? So it does occur.
Yeah.
So that's the mean value for integrals. Remember the mean value for derivatives, there had to have been a point in the interval where the instantaneous is equal to the average rate of change. Well, we have the average, it's equal to the actual function instantaneous somewhere in that interval. That's called the mean value theorem for integrals. Used far less often than derivatives. It's not a huge theme of the class, but it does exist. There has to be a point in that interval where the function is equal to the average. So if we wanted to find it, it'd be x squared minus 2 equals 1. X would be the square root of 3 plus or minus. So that's in our region. Questions on that? Somebody asked, why don't you do a plus c? I'll just,
Oh, here.
if you want to do the antiderivative of both of them, like here. I'll just do general, I guess. From A to B, f of, I'll call it f of x dx. That would be capital F of B minus capital F of A, right? That's the fundamental theorem calculus part 2, because we haven't talked about part 1 yet. That makes sense. So antiderivative of B, we could have tossed a plus c in, minus capital F of A plus c, and they are the same c, so do you see that the c's crossed off?
I do see the C's.
Thank you. So if you're doing a definite integral, this is a definite integral. How do I know it's a definite integral?
It's defined.
Yep, it has boundaries of integration, A and B. It's a definite. If you have that, you do not include a plus. Okay, if it was an indefinite integral,
There would be no A and B.
then it would be 1/4 x to the 4th plus x plus c. That's an indefinite integral.
Wouldn't that have an infinite?
Yeah, that right there is one antiderivative of that. There's infinitely many, depending on what you want your c to be.
That's scary.
How would you even? No.
Oh no. What? No.
Okay, what would we get if we did this?
2x plus. Wait.
You're going the wrong way.
1/3 x
We just.
plus.
Okay, I got a new hat to put.
Alright, try it. Write it down. 1/3 x cubed. And we're evaluating it from 4 to x, right?
I thought it was 9.
Yeah.
Thank goodness.
So we are replacing our x with an x. Are those the same x's? No. Okay, so in calc books or calc things, if you have like 4 to x, you'll never have f of x down here. Generally, they'll do f of t. The reason they do t and not x is because here you would actually be overusing the variable x. You can't have it in this part of the problem and in that part of the problem. You're replacing one x with another x. So this is appropriate way to have it listed out. So then it would be capital F of x minus capital F of 4. Okay, so whatever you have here, that's what your antiderivative will be written with respect to. That was my only point for this. Okay, so if you see why do they have t's and x's, it's because they're different and you don't want to overuse x. Find the antiderivative, then you plug in your x and it becomes in terms of x. Questions? Specific questions from your assignment?